Good morning students. We are studying chapter electricity and how to know that what is the potential difference and what is the importance of potential difference. Now let's talk about electric current. Electric current, I explained you in last video that the flow of charges, the rate of flow of charge is called electric current. It means, so this is a wire and it has some area cross section, and if q coulomb of charges flow through this cross section in 1 second. So the time is 1 second. So we will say the current through the wire is q coulomb, or we can also explain it like this. If this is a cross section and q coulomb of charges is flowing through this cross section in t times, in t seconds, then we can say that the current through the wire I is equal to Q upon T. So we can define the electric current that the rate of flow of charge is called current. What does it mean by rate of? Rate of means magnitude divided by time, or we can say the charges per second is called current. So the current is the rate of flow of charge is called current, and we can also explain it like this. Here we can write the formula of electric current by writing that if Q coulomb of charges flowing through any cross section in t seconds, in t time, we can also write it like t time, then the current flow through the wire is I is equal to Q upon T. So this is the current. So every metal, mostly metals, metals are non-metals do not contain free electrons. So mostly metals contain the free electrons, and if we provide them a potential difference, then what happens? If we provide a potential difference between two ends, the electrons get a direction for their motion. And this flow of charges, this flow of free electrons is called current. So actually the current is the flow of electrons in a metal wire. So we can define the electric current like that. Now what is the SI unit of electric current? So according to the formula, we can see that the coulomb per second should be the SI unit of current. Or we can also write it like ampere. Ampere. We represent this unit ampere by the symbol capital A. So the current is the rate of flow of charge is called current. We represent it by I, and I is equal to Q upon T, where Q is the charge flowing through any cross section and T is the time taken by the charges to flow. So the I is equal to Q upon T. The SI unit of current is ampere and represented by the symbol capital A. So we can write all these things in notebook. Okay, how can I define 1 ampere? Now we know that current is equal to charge upon time. So we can say that 1 ampere should be equal to 1 coulomb upon 1 second. It means we can define it like this, like that. If 1 coulomb of charge is flowing through any cross section in 1 second, then the current flowing through the wire is 1 ampere. You can write this definition in your notebook that the definition of the 1 ampere is if 1 coulomb of charge is flowing through any cross section in 1 second, the current flowing through this wire, through this cross section, through this wire is called 1 ampere. So we can also define ampere like this. We can also represent the current by different units. This is the SI unit, ampere. We can also represent in milliampere. If the quantity of charge is, if the quantity of current is so low, so we can represent it by using the milliampere. So even though in laboratory we also uses the ammeter which measures the current in milliampere. So 1 milliampere, as we use this millimeter and meter, same as we use milliampere, the relation between the millimeter and the meter is same as the relation between the milliampere and the ampere. So 1 milliampere is equal to, we can write it like milliampere is equal to 10 to the power minus 3 ampere. Same as the 1 millimeter is equal to 1 upon 10, 1 upon 1000 1 millimeter is equal to 1 upon 1000 meter. So we can also say that 1 milliampere is equal to 10 to the power minus 3 ampere. So we also represent the SI unit of current, the formula, as the definition of an ampere, and other units of current. Now, instrument which we use to measure the current in the circuit. We always connect ammeter in series. I explained in last video what is the meaning of series and the parallel combination. So, if you want to find out how much current is going through this wire, then we will connect the meter here like here. This is called series. So, this is the ammeter. So, we use ammeter for measuring the current in a circuit, and we always connect ammeter in series. There should be one important condition that ammeter should have very low resistance so that it do not resist the flow of electron. So it's very important that the ammeter should have a very low resistance. I think now we know that what is the meaning of resistance. Resistance is which restrict the flow of charges. Which resist the flow of the electron, free electron is called resistance. So, instrument ammeter we use for measuring the current which we connect in series, and this ammeter should have a very low resistance. Okay, now we can discuss some simple questions based on I is equal to Q quantity. An electric bulb draws a current of 0.25 ampere. First, we should write what are the different values which we have from the question, like electric bulb draws a current of 0.25 ampere. What is this? This is current. 0.25 ampere. This is a current flowing through the wire. For 20 minutes, time is equal to 20 minutes. Now, the most important thing is we know that we always use the values within SI units. Now, this is not the SI unit of time. We know the SI unit of time is seconds. So, we will say 20 into 60 is equal to 1200 seconds. So, first we have to convert all the values in SI unit. So, what you have to find? Calculate the amount of electric charges. It means you have to find the value of Q. So, we will say I is equal to Q T. If we know any of the values from this formula, we can find out the other value. Like if we know the value of I and T, we can find out Q. If we know the value of Q and T, we can find out current. It means I. So here we know the current is equal to 0.25 ampere is equal to Q is, we have to find, and it is 1200. So by multiplying it, we will get 25. 25 is 50 by 20. 25 into 25 and 5, 30. Okay. And 20, 2 decimals. So this coulomb of charge is flowing through the wire. So that's how we find out the value of current. Now, how to get the continuous flow of electric current? That's very important, since we know that all the wires, all the metal wires have free electrons. But it's not happened that the current is flowing through these wires. Though they contain the free electrons, though they contain the free electrons, but the electric current is not flowing through the wire. So how can we get the continuous flow through the wire? So now you know that if you connect the bulb from the wire, now we know that this wire has electrons, and this electron should move through this bulb so that this bulb can flow. But it don't happen. Why? Because the electrons which are present in the wire do not get a flow. So for the flow of electron, what should we have to do? We have to develop the potential difference between the points. So that, what is meant by the potential difference? I explained in last video that potential difference means you are creating a difference between the charges. Suppose this is a battery. What we say? Okay, we develop the potential difference by applying a cell or a battery in a circuit. So suppose this is a battery. Battery is a combination of cells is called battery. So this is the positive, this is the negative terminal. Now we know that this negative terminal contains lots of free electrons and this positive terminal So what will happen? The electron will start flowing from the negative terminal towards the positive terminal. It means by connecting the circuit with the battery or a cell, we provide a potential difference so that the electrons get a flow. And this flow of electron is called electric current. This is called the electric current. We know that the flow of electron, the flow of the charge is called the electric current. So this is the electric current. Now what should be the direction of current? Is it from negative to positive terminal? No, not at all. Actually, we represent the current by the positive ion. We know that the positive ion can't move in a matter. Positive ions are actually, what are the positive ions? I explained in last video. That positive ion is the deficient atoms, the atoms which are deficient in electrons. The atoms which have already lose electrons become positively charged. So these positively charged are not the protons, these are called the atoms. And atoms cannot move in a matter. Since we know that the particles in a matter only vibrate on its own position, it means the atom which contains the positive charge cannot move. It will have the positive charge, but it can't move. It can vibrate on its own position. So what move in the charges? What move in the matters? Actually, the free electrons move in the matter. So we can see the flow of electrons called current, but we can't represent the current by using the direction of the electrons, because we represent the current by the positive ions. So we can say the direction of current is always opposite to the direction of electrons. If the electrons are starting moving from this one to this direction, then we will say that the current is moving in this direction. This should be the direction of current. So direction of current is always opposite to the direction of electrons. Electrons always move from the negative terminal of the battery towards the positive terminal of the battery, but the current moves from the positive terminal of the battery towards the negative terminal of the battery. So actually the current is the flow of electrons, but the direction of current is opposite to the direction of flow of electrons. So this is the direction of current, which is opposite to the direction of electrons. Now you know what happened actually starting the matter. This is a matter having some positive charges. You know the positive charges are the atoms which deficient in electrons, and having the negative ions. Negative ions are the free electrons which can easily move. Now these electrons moving in random direction where we don't get any without any if we don't connect this wire with the cell or the battery, these electrons move randomly in the metals. But what happens when we connect this metal wire with the battery or cell? We connect this wire with the battery or cell, this electron get a direction of flow. It means we know that this negative charge, this negative terminal of the battery, from this negative terminal of the battery, electron will start flowing towards the positive terminal. So it means the electrons, the free electrons which are initially moving randomly in the matter get direction due to this cell or the battery, and then this electron will start moving towards the positive terminal like this. So that's how they get the direction of flow. So this is the direction of how the current is flowing from the wire. Now let us discuss the electric circuit. Electric circuit means in which we have a connecting wire, we have a battery or a cell, we have a resistance band, this can be even a bulb. So a continuous flow in which we have a switch, we have a bulb or a resistance wire, switch, bulb, resistance wire, a connecting wire, and a key and a battery, and we connect all these things so that the current start flowing through it is called the electric circuit. So we can say a continuous conducting path in which we resistor, it can be one also. A resistance, we have more than one resistance, a switch, a battery, and if we connect these all things, the current will start flowing through the circuit. This is called the electric circuit. And how will we present the electric circuit? By using the symbols. So first of all, we should know what are the different symbols which we use for representing the electric circuit. So the symbols are first on the cell. We represent the cell by a small and a large lines like this. This small line represents the negative terminal of the battery and this one is the positive. This is called the cell. I would like to always draw the larger line first and then smaller. Yeah, it's no better. Doesn't matter that कहाँ से connect करें. Doesn't matter which part you are showing the positive, which one is negative. Doesn't matter. So this looks better. Cell on the battery. Battery is in which more than one, which contain two or more than two cells connecting together. This is called battery. Again, this large line show the positive terminal and this smaller one show the negative terminal. This is called the battery. Connecting wire. Connecting wire. Connecting wire is represented like this line, single line. Connecting wire. And then next, joint. Joint, you present the joint like this. This is the meaning of joint. Crossing wire. Crossing wire. This is a wire. And suppose we want to show that the second wire is crossing over it. So we can't represent it like this. This can be joint. So we represent it like this. This shows the crossing wire. And then fixed resistance. Okay. Fixed resistance. Fixed resistance represented like this. This is the resistance. We represented resistance. And next one is the rheostat. Okay. This is important thing. Variable resistance. We will use it in our practical lab. Rheostat. Okay. RHE. Sorry. A little confused here. RHE. Yes. Rheostat. Rheostat is represented by the symbol like this or represented like this. This is called a rheostat. What do you mean by the rheostat? Actually, the rheostat is look like this. This is a standard shape in between, and these are the stand laps. And there is a cursor which can slide over this cylindrical shape structure in which we made a structure by putting lots of wire over it. And by sliding this cursor, we can change the resistance of the circuit. It means if we are using the rheostat in the circuit, we can change the by changing the resistance. Actually, what we are doing, we are changing the current in the circuit. And I will explain you about it when I will explain Ohm's law. After a few minutes, I will explain you the law, Ohm's law, in which I will explain how this rheostat works and what is the function of this rheostat. So we represent the rheostat by this symbol. This is also called the variable resistance. It had to vary the resistance of the circuit so that the current changes and that's why the potential difference also changes. Okay, now the next one, ammeter. We represent the meter by the symbol having positive and the negative terminal. Yeah, ammeter also have positive and the negative terminal like the battery or the cell. Voltmeter. We represent the voltmeter by the symbol. This is called voltmeter having the positive and the negative terminal. Galvanometer. You know what is a galvanometer? Galvanometer only represent either the current is flowing in the circuit or not. It do not show how much is current flowing through the circuit, but it only represents that the current is flowing through the circuit or not. And it also shows that galvanometer, and this is ammeter. This is called voltmeter. Okay. Now key. What key? Yeah, key. Key is just like a switch which we use for on or off. So this is the key, and we represent the key by this such type of symbols. This is called the open key. It will switch off. The current is not flowing. If we open the key, the current is not flow. We represent open key by this or this. This is the open key. And if we switch on, it means closed key. Closed key will represent like this. This is the closed key or like this. This is the closed key. So these are the key and the bulb. Bulb represent like this. So these are the different symbols which we use for showing the circuit diagram. So now, after understanding all the symbols which we use for the circuit diagram, let's talk about the circuit diagram. Okay. You should write all the symbols in your notebook. Now the circuit diagram. So now let's talk about the circuit diagram. Yes, the circuit diagram. Actually, what is the meaning of the circuit diagram? Circuit diagram means the representing of a circuit by using the different symbols of the components is called the circuit diagram. We can also say that the diagram which indicate how the different components are connected in a circuit by using symbols for the components is called a circuit diagram. Circuit diagram is how we use these different symbols in a circuit. And if we use these symbols in a circuit without writing their name, it shows the circuit diagram. So now we know that this is a connecting wire, and suppose we have the resistance wire like this. This is the resistance wire. The resistance wire is on which you have to find out the resistance. So first we will connect the ammeter in series. Yes. So we connect this ammeter in a series. This is ammeter. The important condition for connecting the ammeter is not only we connected in a series, but also suppose this is battery. We know that we have to connect the battery for the connection of electrons, for the connection of electric current. So always this positive terminal of the battery should be there towards the positive terminal of ammeter. This is the positive terminal of ammeter. So here should be the negative terminal. So it's very important that you should know that the positive terminal of the battery should be towards the positive terminal of the ammeter. It's very important. Not only the connection of ammeter in the series, but also the positive terminal of the ammeter should be there towards the positive terminal of the battery. Now, how will you connect the voltmeter? You will connect the voltmeter in parallel with this resistance wire. If you want to find out the potential difference of this resistance wire, then you will connect the voltmeter in parallel with this resistance. So voltmeter is connected like this. Now again, it's not important only to connect the potential difference in parallel with the resistance wire, but it's also important that the positive terminal of the potential difference from voltmeter should be towards the positive terminal of the battery. Again, I'm telling you, it's very important. In MCQ questions, you get such type of questions in which you have the circuit diagrams, and there should be the wrong connections of ammeter or voltmeter, and it will ask that which connection is correct. So you should know that the positive terminal of ammeter as well as the voltmeter should be towards the positive terminal of the battery. So okay, now this is the reverse state. can also represent it like this. Very constant. And then key. This is called the closed key. Closed key means now the current can flow through this circuit. This is called the key. So we can show that the current is flowing like this. Okay, this is the direction of current. Only you will show this direction of current when you have this key or the battery closed. If it is open, that does not happen, that the current will flow in the wire, in the circuit, sorry. So this is called the circuit diagram. So representing the circuit by using the symbols of the components is called the circuit diagram. Okay. Now the most important part of the chapter, that is the Ohm's law. Either it's all the parts are important, but the Ohm's law is, we can say, the heart of this chapter. So Ohm's law. Now let's discuss about the Ohm's law. Ohm's law was given by the scientist called Ohms. On his name, the law is called the Ohm's law. Ohm's law. Now what is this law? According to Ohm's law, at constant temperature and we can say pressure, at constant temperature, actually the temperature is a very important thing that we have to write constant temperature along with this law, because by changing the temperature the situation actually changes, the condition actually changes. So we can say at constant temperature the current flowing through the wire is directly proportional to the potential difference across its ends. What does it mean? It means that if we increase the current in the circuit, then according to Ohm, the potential difference will also increases. And if we decrease the current in the circuit, the potential difference also decreases. So we can say that the current flowing through the wire is directly proportional to the potential difference across the ends. So we can write the Ohm's law, only the two lines, the law have only two lines. But since it's very important to write down at constant temperature, because if we change the temperature, this condition also changes. So we will say that at constant temperature, the current flowing through the wire is directly proportional to the potential difference across its ends. You can write this law by pause this video. So please pause video for writing this law, it's very important. Now, as I told you that according to Ohm at constant temperature, what happened? Current to the wire is directly proportional to the potential difference. So now these two lines is not only the law. You have to also derive this whole law. If the question is write the Ohm's law, since this chapter we will get to the second term. So in second term we will also get short answers type of question. So you have to write down the answers, not only the MCQ. So it means you should know how can we write this law. Not only the two lines of the law, you also have to derive this law like this. Let the current through the wire, you will write let the current through the wire, through the circuit you can also say, is equal to I. And the potential difference across the ends, potential difference across the end is equal to V. Then according to Ohm's law, after writing the two lines law, we will write all these things. Okay. According to Ohm's law, we will see that I is directly proportional to the V, and we will write in the bracket at constant temperature. It's very important that you should write it at constant temperature, because by changing the temperature, the conditions changes. So you will write here at constant temperature. We can also write it like this: V at proportional to I. And we always know that if we remove this sign, we want to remove this sign at proportion, we have to write the constant here. R is constant called resistance. So this is the resistance, and I explain you what is actually the meaning of the resistance. So according to Ohm, if you increase the current, the potential difference also increases. It will changes according to current, or if you decrease the current, the potential difference also decreases. Now, we can't change the potential difference by changing this battery or a cell. Then how can we change the current? So now this reverse state work. Actually, this reverse state changes the resistance of the circuit. So that's why the current in the circuit changes. As the current changes, the potential difference also changes. It means we are changing the potential difference without changing the battery or cell. We have a constant battery or cell, but if we want to change the V or the I, we should use a reverse state. So this reverse state is used for changing the current in the circuit so that the potential difference also changes, and we can easily verify the Ohm's law. So okay, आज इतना ही करते हैं. In next class we will discuss few questions related to Ohm's law and the different combination of the resistance and the series and the parallel combination. Okay, have a nice day.